Alright, hello everyone. We should be working out well. We should be able to see my screen. I am very hopeful. Alright, so we are going to start with week 2 at this point. I hope that week 1 has gone well for you all. Of course, I'm always available via Canvas inbox if and when you have a question. I have had some messages from some students. It seems that Edpuzzle is going to work best in Chrome or Firefox and not so much Safari because of the settings you have to adjust to allow the video to play. This week we're going to look at functions, so it's going to be all about functions. We're going to look at how do I solve functions, how do I create functions, how do I evaluate functions. So we're going to start with the rectangular coordinate system. This may be a review for some, and for some it may be completely new. So the x-axis is that horizontal line. Okay, I always think of them in terms of vertical and horizontal. The y-axis is that vertical line, okay? And this creates a rectangular coordinate plane. The rectangular name because of its shape. The coordinates come because each of your numbers are in a coordinate pair, and it's called a plane because it's what we call space. Okay, it has 4 quadrants. That just means 4 spaces. So here's quadrant 1, 2, 3, and 4, and they're labeled with Roman numerals. Okay, a 1, a 2, a 3, and a 4. We can determine the location of any point in the coordinate plane and write that point as an ordered pair x comma y, always writing the x coordinate first and the y coordinate second. That's kind of tricky when you begin, I think, and I think that I sometimes still, on occasion, if I'm doing a more complex problem, try to flip them backwards. Okay, so if you need to, just write that above each of your numbers so that you know which one's x and which one's y. That's perfectly acceptable. Okay, so let's look at some points, and we'll just label a couple of them. So point A, and I might go through here and I would put my x and my y. I know that it's in quadrant 2 because it has 1 negative number and 1 positive number. Okay, so knowing where the signs are, whether it's positive, positive, negative, negative, or positive, negative, can help you to kind of quickly see, hey, where it needs to go. Okay, so we can just go, we would count 1, 2, 3, and 4, and up 1 to get there, and that's negative 4, comma 1. Okay, you always, when you're counting, always start right here in the center. This is 0. It's not often wrote as a 0, but that is where this is, and it's also called an origin. Okay, because that's where we start with all the points, so it's kind of the original starting point, and then the point is where we're kind of driving to. Okay, so let's do B as well. X comma y. So that's negative, negative, so I know that it has to be down here in quadrant 3. 1, 2, 3, and down 1. Negative 3, comma, negative 1, and that's going to go over top of the B. My greatest apologies. And we're going to look at this one. This one is called the y-intercept. The y-intercept always has a 0 in place of the x. Okay, so the y-intercept no matter what is going to be 0 comma some y value. Okay, that makes that look more like a y because that's looking like a, and then I fixed it. What I do, I made it look more like a number 4. Y'all be thinking it's always a number 4 with my handwriting. Okay, it's always a 0 and a y. And then we found that right here. Okay, and it's 0, negative 4. That's important when it comes to drawing a line and dealing with slope. We always kind of want to start with the y-intercept. Okay, and then this point, 2 and 3 is right here. Okay. Now this is the x-intercept. The x-intercept is the opposite of that y-intercept, okay? And what do I mean by that? I mean that the zero's in a different place. So for an x-intercept, you always have x, comma, some 0. Well, comma, some 0, comma, 0, and it's some x, okay? And that's the formation of an x and y intercept generally. The zeros always hold true for the place that they're at. It's just the x or the y that's going to change. And that's right here at E, so it's 3 and 0. And of course the x-intercept's on top of the x-axis. The y-intercept is on top of the y-axis. Okay? So that's just a general review of the coordinate plane. Okay? So functions in the vertical line test. So a relation is a rule that maps a set of input values to a set of output values. Okay? So that just means for some value I've put in, I got something else out. Okay? So it's kind of a matching. A function is a rule that maps a set of input values to a set of output values by assigning each input value to exactly one output value. That is the important thing. Exactly one output value. Okay? If you see an input go into more than one output, then it's not going to be a function. And we'll look at some examples of that. Functions can be represented by using tables, a set of ordered pairs, maps, diagrams, equations, and graphs. So you really have a bunch of different ways to see these in a bunch of different representations. Some students will love one representation more than another. So you might see something and you want to go to Desmos or to the TI-84 and graph it to try to look at it because you're more of a visual person and you want to see a graph. Some people will go to wanting to make a table every time because they like tables better. It's ultimately up to you. For me, the important part is you understanding whether it's a function or not and being able to identify that with whatever method works for you. So the vertical line test determines if a graph represents a function. A vertical line will only intersect the graph of a function at most once, indicating every input value is assigned to exactly one output value. If a vertical line intersects a graph more than once, the graph does not represent a function because an input value maps to more than one output value. Okay? So let's look at an example. Determine if the following relations are functions. For functions, write the equation that represents the relationship. For a non-function, explain why not. So let's look. So -4 goes to 2. Do I see any other number going to 2? Okay, that's good. 0 goes to 6. I don't see any other number going to 6. 7 goes to 13. I don't see any other number going to 13. 9 and 15. That's good. I don't see. So none of these numbers are going to more than one value over here. They're all just going to 1. Okay, so we're good. So this must be a function. Function. And let's write that equation. So let's see what's happening to get from one value to another. So it looks like we might be adding 6. Because 0 plus 6 is 6. -4 plus 6 is 2. 7 plus 6 is 13. 9 plus 6 is 15. So it looks like I'm adding 6. So this will be y is equal to x plus 6. Okay. Now let's look at this one. I can draw a vertical line here and here, but wait, what if I draw a vertical line here? I'm hitting both of these lines. I'm hitting here, and I'm also hitting this other line here. And I cannot have that happening. I can only be going and x can only be going to that one y value. So this is not a function, okay? Because it does not pass the vertical line test. Okay. This dot here, this means that that number's not included since it's an open circle. But it fails the vertical line test before then, so that doesn't concern us at this moment. It might in the future, but not right now. So let's look at this. -2 goes to 4, 2 goes to 4, 0 goes to 0, -1 goes to 1, 1 goes to 1, 2 goes to 4. Okay, so it looks good. And I don't see a number going. I don't see a number going over here going to more than one of these. Okay, does that make sense? So I don't have -2 mapping itself to 2 and 0 both. Okay, -2 is only sending itself to 4, 2 is only sending itself to 4, 1's only sending itself to 1, -1's only sending itself to 1, 0's only sending itself to 0. These values can only go to 1y. Okay? It's okay if distinct ones of these share the same number over here. So example, -2 and 2 both go to 4. That's fine. Okay? It's fine for you to have more than one of your x values going to the same y value. Okay, that's fine. It's not okay if you have an x value going to two numbers over here. So if this -2 went to 0 and 4 both, that's a no. Okay, so each input can only go to one output. Okay, that's a question I always get. Does it matter that that those numbers are sharing the 4 or sharing the 1? No, that doesn't matter. It only matters when this value goes to more than one value on the other side. So yes, it is a function. So let's see, what type of function is it? Okay. Well, let's think about this. What can I do to -2 to get to 4, and what can I do to 2 to get to 4? Well, one's negative and one's positive. So the only thing, if I think back to prior math that I may have had in high school, is that a squared function or a quadratic function is what could have a negative and a positive answer both go to the same answer. So this must be a quadratic, and we'll examine these functions further in the course. But a quadratic is the only one that'll have a negative and a positive both go out to the same function, and that checks because 2 squared is 4, -2 squared is -2 times -2, which makes positive 4. Okay, let's look at an example here. So 2 goes to 3. Do I have another 2? Nope, so that one checks. 3 goes to 1, but wait a minute. I have 3 again. 3's going to 1 and 9. That's a no, because 3 can only go to one number in the y set, like I showed earlier on that graph. So this is not a function, because 3 goes to 1 and 9. Okay, and we can't have that. It can't be going to 1 and 9. Alright, so let's look at this one here. It looks like it's going okay, right? I don't see it arguing that one of these persons has 2 birthdays, right? So every person has only 1 birthday. So yes, it's a function. So more than one person can be born on the same day, right? But you can't have 2 birthdays. So if we had saw that it said that Jamie had a birthday on March 5th and July 19th, then that would not be a function, because how can you have two birthdays? But it is a function because we can share the birthday, because there's several people that are born each day. Okay, so we often use acronyms as shorthand to help make texting more efficient. Function notation is the shorthand that helps make math more efficient. Acronyms in texting is a language that needs to be learned, just like function notation is a language that needs to be learned. The more we're exposed to it, the easier it is to understand. Okay, so you kind of have to know that the language, right? Because somebody might send something to you and it makes no sense because they didn't understand what the texting acronym was, like the examples up here. That's kind of the same thing for function notation. Once we know what it is, we can work with it pretty well, but until we know what it is and what it means, we kind of struggle. Okay? So that's why vocabulary is very important. Math, language in English is very important in math as far as understanding what to do, whether we like to admit it or not. So when a function in two variables is defined by an equation, we often use function notation. Let f of x be a function. Then f is the name of the function. X represents an input value of the function. F of x represents an output value of the function corresponding to x. You notice how I'm reading this as f of x. Okay? F of x, or we're saying f is a function of x. Okay? So we just kind of say f of x as shorthand, but it's really saying f is a function of x. So f's doing something to x, right? It means to evaluate the function f at the input value x to get the output value. It does not mean to multiply f and x. Okay, so that's an important note. You normally see those parentheses and you think, hey, let me multiply. We're not multiplying, we're reading this f of x. So f is a function of x, since x is the input. The function y equals the absolute value of x. So this is the absolute value symbol, okay? I'll make that note for you. Can be written in function notation as f of x equals the absolute value of x. So at this point, f of x is replacing your y. Okay, you're used to seeing a y. Now you're going to see a lot more of f of x. And it's not always f of x. Sometimes it's g of x, h of x. The letter will change based on the situation or the word problem and what we're measuring. They all mean the same thing. It's just kind of nice whenever you're dealing with more than one function to be able to name them different letters, because if we all had them as y, it gets a little confusing on us. So rewrite the equation in example 1a using function notation. So I wrote that up here as y equals x plus 6. I can rewrite that as f of x equals x plus 6. And for the other one, we had y equal to t squared, because we were using t that time instead of x. So we would rewrite that as f of t is equal to t squared. So these variables match. Okay? So if it's an x, it's an x. If it's a t inside of those parentheses. Alright, so let's look at example 5 here. Suppose a gallon of Seahawk paint covers 250 square feet of wall. Let g of x, why is it a g this time? Because we're talking about gallons of paint. See, it depends on the situation, what letter you're going to use there. Represent the area of the wall in square feet, and let x represent the amount of Seahawk paint in gallons. Okay, so let's create us a little table. I'm going to have x and I'm going to have g of x, and you all are used to seeing a table with x and y. Okay, so whenever I've covered 0 square feet of wall, how many gallons of paint have I used? 0, because I ain't even started yet. Okay, now it says 1 gallon will cover 250 square feet. Okay, so let's think. If I had 2 gallons, I'd need what? Another 250 square feet of wall painted. So that makes what? 500. So I've added 250. Okay, if I've got 3, well, another 250 square feet are covered. So I'm going to add 250 again. And let's just do one more for good measure. So I've covered another 250 feet. So that becomes 1,000 square feet that are covered. Write the equation. So it's going to be g of x, because we're talking about gallons of x paint. Okay. And what are we adding each time? 250. Okay. So we're doing 250 times the number of gallons. And we can test this to make sure it works real good. So maybe we want to see how many square feet of paint I can cover with 3 gallons. So 250 times 3, what does that get me? 250, 500, 750. So G of 3 is equal to, or G of 3 gallons of paint, is equal to 750 square feet covered. Does that match what we had in our table? Yes. So our function's good. Okay, and I meant to insert a piece of graph paper for you all here. So your graph's going to look better than mine, like always. But, see, we already off to a rough start. It went up in the ceiling. Okay, so y'all's is going to look better. I need a ruler or something to hold up to the computer screen. Okay, so we're just going to kind of rough estimate my graph. Okay, and I got 250, 500, 750, and 1,000. Okay, and at 0, 0, and then we had 1 at 250. We had 2 and 500 gallons, 3 and 750 gallons, and then 4 and 1,000. And that may be just a little bit above my 1,000, and I didn't mean it to. Your graph is going to hit all the points, but mine's a little crooked. That's why I meant to put us a piece of graph paper in there. Okay. Now let's work on evaluating and solving. Sorry about that. Sometimes my mouse wants to argue with me. So we're going to evaluate and solve for zeros, x-intercepts. So x-intercepts are called zeros. As we get on into the course, they'll be called some other things. There's a lot of words for x-intercepts. It's one of those things where when you know the vocabulary, you know what to do. So we're going to let f of x be a function. We're going to evaluate giving a particular input and find the output. Okay, and we'll use substitution. I'll let you all read that. I'm not going to force you all to let me read that. I'll show you the examples. Given a particular output, you find its input. The real zeros, x-intercepts, I told you they could also be called roots. Okay, they're called roots, they're called zeros. A lot of names. Are the inputs that give it an output of 0. Okay, and real meaning that they're not something we can't see on the graph, right? So the y-intercept of a function is the output that corresponds to the input. And just like I showed you all earlier, it's always 0, y. Okay, so let's look at us an example. The following table represents the annual salary of a teacher with a bachelor's degree in North Carolina Public Schools, effective July 1st, 2018. And unfortunately for public school teachers, this looks very similar now in 2025. Okay, so you're going to evaluate the intercept S2. S2. Okay, so let's look at it. at 2. So that means that a second year teacher makes how much? $37,000. Okay. Solve and interpret S of x equal 40,000. For this one, you're looking in the S of x column and seeing where you see 40,000, and it's right here. So I'm saying, well, what year does that match up with? 5 years. So x equals 5. Okay. So a teacher with 5 years of experience makes $40,000 a year. Let's add that part a year. Okay. So that's interpreting from a table. Okay, now let's interpret from a graph. And I got one of these nice graphs. So the graph below represents the profit in millions of dollars of a company since the year 2000. Evaluate and interpret P of 5. Okay, so I'm looking for 5 years. Okay, so I'm looking for 5 years. Okay, so let's see, 5 years. That's what? $2 million? $2 million in profit. 5 years after 2000, or what could we say? That was what? In the year 2005. Because 5 years after 2000 is 2005. Okay. Now, -2, that's where I'm looking for on the y. This is when I'm looking on the y-axis, okay, when it equals, because I'm trying to find t times since. So that's what, 7 years? So t equals 7 years. So the profit was -$2 million. 7 years after 2000, or 2007. Evaluate and interpret P of 10 minus P of 9. First, I have to find those values. So I'm looking on the x again, because remember this is the x, or in our problem it's a t. And that's 10. So that's 10 million. And then in 2009, it was 2 million. So that's 10 million minus 2 million. 8 million. So how would we interpret that? The company had a profit of $8 million more in 2010 than 2009. Solve and interpret for 0. Okay, 0. So 0 has 2. Has 2 at year 6 and year 8. So how would I write that? At years 6 and 8, the profit was 0 now let's go through and solve this. So evaluate for f of 0. That means that x is 0. So we're going to plug that in. So I'm going to rewrite that. F of 0 equals 2 times 0 squared plus 7 times 0 minus 15. Okay. Well, 0 squared is just 0. 2 times 0, 0. 7 times 0, 0. Minus 15. So what do we have? F of 0 equals negative 15. Okay, that must be the what? The y-intercept. Because we know that when we have 0 in the x, but a value in the y, it is the y-intercept. What does your answer represent on the graph of f? Okay. So we've got our function. So this time we got 0 equals 2x squared plus 7x minus 15. So we're trying to find the zeros. Okay, now there's a few ways to approach this. I would probably take the root of factoring with that slide and divide. So we're going to multiply by 2 to get this to where it's just x squared, sum of x squared plus 7x minus 30 equals 0. Don't forget that, because sometimes I'm bad for that. I'll get the right answer, but I forgot to bring that piece down. So what'll multiply to get 30? We got what, 3 times 10, and that's what's going to work in the end, isn't it? A negative 3 and a positive 10, because 10 minus 3 is 7, and 10 times negative 3 is negative 30. So I have x plus 10, x minus 3. Remember, we use slide and divide though, so we have to divide that 2 back out. Okay, so divide by 2, divide by 2. It works out well on this. This just becomes x plus 5. But this is x minus 3/2. And that's not good. We got to bring the 2 back out in front, right? So it becomes x plus 5 times 2x minus 3. Okay, so now we have to set those equal to 0 to solve. So what, x equals negative 5, 2x equals 3, and this is going to kind of run into the next problem. X equals 3/2. So your roots are x equals negative 5 and x equals 3/2. Okay. So those are the roots, the zeros, and what else do we call those? The x-intercepts. 3 names for the same thing. Okay. Now we're going to evaluate. I'm going to leave you all this one to try on your own, because I don't want this video to be too horribly long here. So we're going to evaluate for negative 2. So we have f of negative 2 equals 2 times negative 2 squared plus 7 times negative 2 minus 15. Negative 2 squared is positive 4. 7 times negative 2, well, that's negative 14. So I could have just wrote that with a minus sign instead of bringing both of those. Okay. 2 times 4 is 8. Negative 14 and negative 15 together, those make what? Negative 29, right? 8 minus 29, that's negative 21. And then it says what ordered pair? Well, the x was what? Negative 2, and the y is 21. Okay. This one wants us to replace the x with x plus h. Okay, so it's going to look like this. And then we would just solve it down. So we know that this means I've got 2 of these. Let me go ahead and distribute. 7 times x is 7x, and 7 times h is 7h. Okay. Now we're going to use FOIL. Keep the 2 out front. X times x, x squared, x times h. It's going to be xh. X times h is going to be xh, and h times h is going to be h squared. Okay. Then I'm going to add my 7x, my 7h, and that negative 15. Now the 2 has to go to all of this. Well, there's 2 of these already. So that's 2xh. So I'm just going to write that. So 2 times x squared is 2x squared. 2 times 2 is 4, so that's 4xh. 2 times h, excuse me, is 2h squared. 7x plus 7h minus 15. Okay, and please rewind the video if you need to. I just did that a little quicker because I don't want this video to be 2 hours long. Okay, now this just says to add h. That just means you add h on the end. Okay, because it didn't say to replace the x with x plus h. It just says add h on the end. So that one's just going to look like 2x squared plus the 7x minus 15 plus h, because it just said add h on the end. Are they equal? No. Okay. Are you evaluating or solving, and what ordered pair is on the graph of G? Okay. So we're solving. So we're going to replace G of 4 is equal to, x is going to become 4. 4 squared minus 4, and 4 plus 12. Okay. 4 squared is what? 4 times 4. 4 times 4 is what? 16. 16 minus 4. 4 plus 12 is 16. 16 minus 4 is 12. 12 over 16. What'll that simplify to? What goes into 16 and 12 both? Is it 4? I think it's 4. So that makes what? 3/4. And then it says what ordered pair? Well, this was the x, and this is the y. Okay, so it's going to be 4, 3/4. Find all the values of x for which g of x equals 3. Are you evaluating or solving? What ordered pair is on the graph of g of x? Okay, So this time we're what? We're going to sit through this and evaluate it. So now it's equals, so x squared minus 4, x plus 12. This goes back to what we reviewed last week and how I don't like to have these fractional pieces, and I can just multiply it out by multiplying on both sides. And then, you know, kindly distributing. So that means all I've got over here is x squared minus 4. This will be 3x plus 36. Okay. Now I need this to look like a quadratic. I need it to be, whoa, that's an A. I need it to be 0 equals x squared plus bx plus c. Okay, I need it in the general quadratic form. It's not there yet, is it? It's kind of everywhere. So let's make that work. Okay, and we just subtract these over. So then it becomes x squared minus 3x, and the 36 has to go over too. So that's negative 40. Okay, so now we're good. We're in normal quadratic form. So now we need to what? Our favorite friend, factor. So let's think of the factors of 40 that'll also get me 3. It ends up being 5 and 8, right? Because 5 times 8 is 40. And 5 minus 8 is the negative 3. And 5 times negative 8 is negative 40. So we're good there. So we're going to have 0 is equal to x plus 5 and x minus 8. So x plus 5 is going to equal 0. X minus 8 is going to equal 0. You're going to deduce that 5. You're going to add the 8. X is equal to 8. Okay. And what ordered pair is on the graph? So negative 5 and 3 must be on the graph. Now would 8, that you have to look at it and see, is 8 also on the graph? Okay, so it tells you that negative 5 and 3 are on the graph, and 8 and 3 are both on the graph, because remember this is a quadratic that we've got, so it should have 2 x-intercepts. 2, 1, or none. Okay. So we already practiced one on finding the x-intercept right up there in letter B. Okay. So this one I'm going to leave for independent practice. Find the y-intercept of g of x. Are you evaluating or solving? Okay. Well, we know that the x is what on a y-intercept? The x is 0. So we're just going to replace that. G of 0 is equal to 0 squared minus 4 over 0 plus 12. 0 squared is just 0. 0 minus 4 is just negative 4. 0 plus 12 is just 12. What can I do? The same thing we had earlier. 4 is the GCF. Okay, that's going to give me negative 1 over 3. So we're going to have 0, comma, negative 1 over 3 as the y-intercept. And that is going to be on my graph. Okay. Given g of x is equal to x squared minus 4, x plus 12, find g of negative 3 over x. Okay. So that one is going to take a little bit. So we're going to g of negative 3 over x. Okay. So this is going to become negative 3 over x squared minus 4. That's going to be negative 3 over x plus 12. Okay, so I'm going to have to go through here. Negative 3 squared is 9. X squared is x squared minus 4 over negative 3x plus 12. So all I had to do here was do my exponents. Okay, so I've done my exponents, so I'm good on that part of the order of operations. Now, I need to get this to where the fractions are kind of lining up and I've got the right common denominator and stuff like that. So let's try to get rid of that x squared. Okay, so I think that's going to work because we don't want fractions in both areas. Okay, so I'm going to try to get rid of this x squared. By multiplying it. Okay, so that means I'm going to have 9x squared over x squared minus 4x squared. Then I'm going to have negative 3x squared over x plus 12x squared. And this is going to work out really well for me. Okay. Now, this is a point where whenever you've got one on your own, you've just got to kind of look and see what these are to figure out how to get rid of those fractions. So I'm going to show you in a minute how this worked out. So this cancels this. So then I'm left with 9 minus 4x squared. X squared divided by x is just what? X on top. So this x and the 2 are eliminated, so it's just negative 3x plus 12x squared. Okay. So now it's without fractions within fractions. And you could probably go on down further if you want to and factor that if the problem asked. Okay. But that multiplying by x squared just kind of worked out for me because I knew I had one x here. But if I have x squared and an x, that'll get rid of this x and just leave me with x when it divides out. And that just divides out to 1, so it worked out. Okay. Example 10. The graph of a function f is shown. Find f of negative 1. So I'm finding negative 1 on the x. And that is negative 4. Find the values of x for which f of x is 2. Remember, this is the y, so I'm going to find 2 on the y. That's going to go to 2 places. It's going to what? 1 and negative 2. So x is going to equal negative 2 or 1. Example 11. Given the following graph, mark the points representing the statements and label their coordinates. So f of 0 equals 2. So f of 0 equals 2. So that's going to be 0, comma 2. Because this was on f. This one's on g. This is 0, 0 on g. That's right here. Okay. This is negative 3 and 0. 3 and 0, and 9 and 0, because it says they all equal 0, and that's on the function f, so I'm on this wiggly one here. So negative 3 and 0 should be right here. 3 and 0, and 9 and 0. Okay. So this one is what? 2, comma 1 for both f and g. And that's where they intersect right here. Okay, so that's where they intersect. Okay, and this is kind of vocabulary. Okay, so there can be 0, 1, 2, 3. We know that those x-intercepts are the roots. You can only have 0 or 1 y-intercept. Using function notation, how do you find the real zeros? Well, we said that that was f of x is equal to 0. Using function notation, you plug in 0. How do you evaluate this? F of 3. How do you evaluate this? F of x equals 3. So that's when we erase f of x and replaced it with 3. So that's just a recap of what we had done. So the x-intercepts are where we cross the x-axis. The x-intercept is at negative 3 and 0. The y-intercept is right here at 0, 0. This does not cross the x-axis, at least where we can see, but it does right there at 4. Okay. And we'll do maybe 1 or 2 of these. These I feel like y'all are pretty well versed in, because you would subtract the 9 over and then you just apply what we did earlier with the slide and divide. So I think y'all are good with these, because we did one like this earlier. This we haven't done something like. So this we're going to solve so that it so the absolute value is by itself. So right now I've got x minus 5 minus 2 equals 0. Now I'm going to add the 2. X minus 5 equal to 2. The important thing to note with these absolute values is, just like a quadratic, you have 2 answers. You have a positive 2 and a negative 2 to test. Because remember, it could be negative in the absolute value and turn out positive, or it could be positive in the absolute value and turn out positive. So there's 2 options. So x equals 7 and x equals 3. So 3 and 7. For this one, you're replacing x with 0. So 0 minus 5 minus 2. That's what? Negative 5. But the absolute value turns everything positive. So it's 5 minus 2, which is 3. Okay. So this one, we'll see if we can do something to it, but I think we're going to find that there's nothing we can do. So let's first multiply that x over Leaves me 0 is equal to the square root of x plus 13. I can subtract 13. So since that's a negative, we know that there's not going to be a real solution. So there's not going to be any answers there. Now let's try for y-intercept. But for the y-intercept, what are we going to be plugging in for x? 0, right? Am I allowed to divide by 0? I can't divide by 0, right? Because that's undefined. So no. Okay. So here's your interval notation. We're going to represent the following sets using interval notation. So this says x is an element of R, given that x is greater than or equal to 6. So that means that x could be anything larger than 6. It says equal to. Remember, equal to has these. Okay, so if you got this or this symbol, it's got those. If you've got this or this symbol, you have parentheses. So now let's look at this one. This one says x has to be less than 10. So 10 is the large number. It can be anything smaller, so negative infinity. That doesn't have a line under it, so it's a parenthesis. This says that x is between negative 4 and 13. Well, it's got to have a parenthesis. This one's got to underline, it's got to have a bracket. Okay. This says it just cannot be 7. Okay, so it could be negative infinity to 7. Remember, not including 7. Parenthesis means not including 7. So it could be negative infinity, could be 6, could be 6.999, but cannot be 7. We're going to union or connect those. This is the union symbol. Just means to connect. Okay. So it could be anything bigger than 7 to infinity. Just cannot be 7. So that's what this shows, that it cannot be 7. Okay. So anytime you have an OR situation, you're going to have a union. Okay. One or the other. Okay. So this one could be what? Negative infinity to negative 9, because it says anything smaller than negative 9. This says x is anything greater than negative 4. Not greater than equal to, just greater than. So that'd be negative 4 to infinity. And I'll leave the last two for you all to inspect. So we will pick up with linear inequalities in another video. I thank you all for watching this lecture. Please, as always, reach out with any questions.